Hey guys, welcome to my channel. Hope all of you are doing absolutely fine. In this chapter, I will be talking about Docker. What exactly Docker is and what all are the components of the Docker. By the end of this video, you should be having a fair idea on what exactly Docker is. Once again, just to be very clear, I will be explaining you the concept in very general terms, but yes, you can always get in-depth knowledge by referring to official Docker site. So let's get started without wasting much time. So, coming to our topic, Docker. There is a whole hype going on in the market around Docker. So, it becomes very crucial for you guys to have a basic understanding about this concept. Although I would be covering this topic in depth, but for those who just want to get to know about Docker concepts, can check out my initial videos on this series. So to understand the concept of Docker and why it's so relevant in today's scenario, we have to understand the issues that was faced earlier in old days, which is now addressed by Docker of course. Let me explain this by a simple example, just to make sure the concept is clear. Consider a scenario where a developer is working on a project for a client. Now, if you see the Python version that a developer is using in this scenario is 2.7. Now the whole code base written by developer is dependent on Python 2.7 version. So far so good, right? Now on completion of the project, developer ships the code to client, but guess what? On client side, Python version installed is 3.7, which causes the code to fail as it's not compatible with Python version 3.7. Reason being, it was developed using Python version 2.7. Now this creates a lot of problem to both the client and the developer, and eventually eats up a lot of time and effort to address this issue. Thus there was a need to make sure the code running on developer side must run on client side without any environment changes. So this can be achieved by using Docker. Now let's see how Docker addresses this issue. Now, as you can see in the presentation, both client and dev system have Docker installed and running. Now, developer will create a project for client in a container. We will get back to this later, but for now consider a container as a virtual machine where all the code base and dependencies are installed. So, as I said, developer will create a new container and install all the needed libraries and packages that is needed for the code base to run and package it as an image. Now this image will be shipped to client on project completion, and on client side, client will basically deploy this image in his system using Docker. The difference between the image and container is when image is in run mode, then it is called a container. That's it. Now even though the client machine has Python 3.7 installed, the image file shipped by developer consists of all the packages and libraries needed to run the code on client side. So as you can see, source code running on client Docker host will use the Python package provided in the container itself rather than Python version installed in client system. So by this approach, environment related issues on client and developer system is fixed. Hope this makes sense, right? Now you might think container looks similar to virtual machines, but guess what? They are not. There is a significant difference among them. Let us see this in detail. As you can see, a container runs natively on Linux and shares the kernel of the host machine with other containers. It runs a discrete process, taking no more memory than any other executable, making it lightweight. By contrast, a virtual machine runs a full-blown guest operating system with virtual access to host resources through a hypervisor. In general, virtual machines incur a lot of overhead beyond what is being consumed by your application logic. But still, we can't say Docker is a replacement of virtual machine because virtual machines are relevant in some of the scenarios even today. So let's move ahead to check out the components of Docker. Majorly, there are three components of Docker, that is client, Docker host and registry. Now coming to Docker daemon, the Docker daemon listens for Docker API requests and manages Docker objects such as images, containers, networks and volumes. A Docker can also communicate with other daemons to manage Docker services. Coming to Docker client, a Docker client is the primary way that many Docker users interact with Docker. When you use commands such as docker run, the client sends this command to Docker daemon, which carries them out. The Docker command uses Docker API. The Docker client can communicate with more than one daemon. Now coming to Docker registries, a Docker registry stores Docker images. Docker Hub, for example, is a public registry that anyone can use, and Docker is configured to look for images on Docker Hub by default. You can even run your own private registry if you want. When you use the docker pull or docker run command, the required images are pulled from your configured registry. When you use the docker push command, your image is pushed to your configured registry. Don't worry about the commands as of now because we will cover those in subsequent tutorial videos in this series. So that's it from my side on what is Docker. I tried my best to explain Docker in simple terms. You can continue watching my subsequent videos in this series to get more insight on using Docker. Please do like and subscribe to my channel if you found this video helpful. Thank you. See you later.